Hello again and welcome. My name is Michael Fudge. This is our Learn to Program in Java series. We're up to Lesson 16. Lesson 16 will cover exception handling. On the agenda today for Lesson 16, we'll talk about errors. What are they? How do they occur? Exceptions. What are exceptions and why you need them? We'll talk about the try-catch statement, which is a block of code we use to handle exceptions. And then, of course, we'll look at best practices and reasons you should use exception management in your programming. Let's start out by talking about errors. Exceptions are designed to handle errors, but what are errors? Errors are conditions which occur in your program, and they cause that program to stop running or terminate. We've seen this before, where you type in bad input, and next thing you know, you see the red text in your program output, and Java stops running your program. Sometimes we don't want our program to stop running. We want to detect the error, handle the error condition, and then continue running our program. There's really two types of errors that occur. There's user error, which is bad input. Somebody types in something or does something that the program cannot handle, and therefore it terminates. And then there's programmer error, which is we write our code in a way that a certain condition is hit, and then an exception occurs. And we've seen this kind of thing when you're looping through an array and you index a value of that array outside the boundaries of the array. You get an index out of range exception. Some of these errors are easier to handle than others, and some are not. It really kind of depends on the circumstances. But the good news is that every single error that we can possibly encounter can be handled. The way we handle these errors is with the try-catch finally block. So let's explain this in a little more detail. When you're writing a program, if that program has a chance of causing an error, Java will raise what's called an exception. And an exception is a variable of type exception. When the error occurs, if we don't handle the exception, we just get the red text that we usually get when you run the output, and then the exception is displayed in our console window. If we want to handle our exception, the code that possibly could generate the error should be surrounded by a try block. You can see I have a try keyword and then a block. If I put the code between these two curly braces that has a potential to raise the exception or throw the error, as we say, if I put the code in there, when the error occurs, rather than terminating, the code will jump down to this catch block, where I can then do something with the exception that I've caught. I can either print it out or log it or clear whatever error condition may occur so that I can continue running my code. The last bit of this try-catch finally block is obviously the finally keyword, and what happens in the finally block is usually cleanup code. It's code that we run regardless of whether try finishes successfully or the catch block is actually the code actually jumps down to the catch block. Regardless of whether or not that happens, the finally code always executes. This type of block is much cleaner and efficient than what we used to do with error checking. Before constructs like try, catch, finally, we would resort to things like putting additional parameters in our methods that detected error conditions. We put a lot of if statements around to try and catch really weird boundary errors and things like that. It was really a mess. The beauty of this type of block is that you don't really have to worry about errors. You just have to ask yourself, can an error occur in this portion of my code? If the answer is yes, then you surround that code with a try, catch, finally block. And then deal with the exceptions as they occur. So you might be asking yourself at this point, when should I handle errors using exceptions? And the answer is pretty clear. When your code has a chance of causing an error and you need to handle that error gracefully, that is, you do not want your program to terminate, you should probably use a try-catch block. When you handle the exception, you will prevent your code from terminating, and you could usually do things like try to clear the exception, try and clear the code out that caused the exception. You probably want to log the exception so that you know these types of errors are happening in your code, either by printing them to the console or writing them to a file. Some examples of when you want to handle errors. Usually anytime you're getting input from the user, because you don't know what the user is going to do, so you want to try to handle all the situations of user input. Anytime you're reading, writing to a file, because you never know, is the disk not going to be available when I'm trying to read that file or write to that file? Whenever you're trying to access resources outside your control, like let's suppose you're programming a game and you're using a gamepad, you might want to verify via a try-catch block that the gamepad is first connected to the computer before you start to ask for input from the gamepad. These are all examples of when you'd want to use an exception, but generally speaking, when you think about your code, you have to ask yourself, is there a chance that I can have an error in this code, and if so, do I want to handle that error, or am I okay with the system just stopping this program from running and just reporting the error at the console? Okay, it's demo time. I have two demos that we will go through. The first demo will just walk you through the basics of exceptions and the try, catch, finally block. And the second example will show you why you want to make your own custom exceptions, so that when you throw particular errors, you know the source of the error because of the name of the exception. Okay, let's get started. Here I am in my NetBeans IDE, and I have a project that I've opened up called Exception Basics and one class called Exception Basics, and I'm just going to kind of walk you through the basics of why you'd want to use an exception to handle various input. Now I could write this type of program. I've written it before, but you probably never thought long and hard about what happens if someone doesn't follow the instructions you give them. So I'm going to do a little copying and pasting so you don't have to watch me type. Okay, my typing's complete. And how many times have you seen a program like this before, where I ask you to enter an integer, I accept that integer, and then I simply print out what you entered? I mean, you've seen this program run quite a few times already. And when I run this program, you'll see it says enter an integer, and I can type in a 5, and it says you entered 5. That's fantastic. The real interesting thing is what happens when I don't enter an integer. If I run the same program again, and then this time it says enter an integer, and I'm going to enter my name, and you'll see it throws an exception called Java util input mismatch exception. So let's see if we can write code to handle this exception, and rather than exiting the program like this with this obscure exception and stack trace, it kind of gives the user a little more graceful message. So again, the rule of thumb is the code that can throw the exception is right here. So what I need to do is I need to take this code and then any dependent code. So for example, it's dependent on input, which is up here, which is of class scanner. And I need to surround this with a try block. So here goes, try. Let's get the rest of this working. And then I'm going to say catch input mismatch exception E. Now, what do I want to do when I catch this? Well, of course, I need to include that. So I just imported that up here. What do I need to do when I catch this exception? Well, I could do a couple of things, but I think what I'll say is something like this. How about you didn't enter an integer? And I guess that's good enough for now. Let me just reformat my code. There, that looks much better. Now let's run it. It says enter an integer, and I'm going to put in Mike. And now rather than barfing out a stack trace and an exception, it goes down here in this catch block, handles the exception, and then prints out this message instead. If you don't believe me, I can trace through it and show you if we go through it a line at a time. So I'm going to hit F7. Enter an integer, Mike. And you can see it jumped immediately into the catch block. And I now have a variable e of type input mismatch exception, and this variable e has a bunch of values to it. So that indeed did work. So you can see the value of exception management, because rather than me having this program terminate, I can gracefully handle the exception in code. Let's finish this example up by making it completely useful and surrounding this code with a while loop so that it keeps asking me for input until I enter an integer. This is something that you probably thought about doing before but just weren't able to do. Now that you know how to use exceptions, you can do this quite easily. So first thing I'm going to do is I'm going to need some kind of condition that tells me it's time to exit. And I'm going to use a Boolean for that. I'm going to call it done. Done is false. So we're not done. And I'm going to say do all of this while not done. And let me reformat this code. There we go. So what I'm going to do now is I'm going to iterate over this code here until this is true. Right now it's until it's false. Right now not false is true. So what I need to do is after I accept input, if this throws an error, it's going to jump down here and it's not going to execute this next line here. If I do type in a successful int, it will go to the next line. So done is true here. I mean, it looks kind of silly, but let's just think about what happens. It's going to do this, do this. You type in something that isn't an int, it's going to jump down here. Then it's going to go back up here and repeat. When you finally do type an int, it's going to do this line of code here. And then this is now going to be false and the loop's going to stop. So let's run it, and then if you want, we'll trace through it. So enter an integer 10. Ha ha ha. You didn't enter an integer. How about Mike? You didn't enter an integer. 5. You entered 5. Beautiful. And let's just, for kicks, let's put a breakpoint here. And let's give it a debug. So here we are, scanner input. And I'm going to step through this code. Now it's asking me to enter an integer. I'm going to enter Mike. Now watch what happens. When I press enter, it's going to skip line 16 and jump right into the exception. See that? So now if I go back up here and continue and step through it again, now it's asking me for an integer. This time I'm going to put in a valid integer. And now it drops down to line 16, executes this code here. Now my exit condition is no longer true because not true is false, and I exit the do while loop. So that's how that works. Try catch. Now let's add one last wrinkle here, the finally. The finally block always executes whenever the try or the catch execute. And we generally use the finally block for cleaning up the code that we started inside the try block. So imagine you do a bunch of work inside try, but you only get halfway done because you throw an exception. The finally block is where you can kind of detect what happened and then hit the undo button if you need to. Or sometimes maybe you start the work in try and then you hit catch, and then because you caught the exception you undo everything, but then regardless of whether try works or it doesn't work, you need to do some cleanup code. So you would do that down here and finally. What I'm going to do in this case is just put a simple message here so that you understand what finally does and when it runs. So this happens whether the exception occurs or not. So let's run it one last time. Enter an integer. And then it says you didn't enter an integer, and it says this happens whether the exception occurs or not. See that? And then I can actually enter an integer this time, and it says this happens whether the exception occurs or not. So it always executes the finally block regardless of whether try completes successfully or whether an exception is thrown inside try and the catch block comes up. So that's try, catch, finally. That's error handling via exceptions. Really not much to it. In the next example, we'll take a look at writing your own custom exceptions. But before we go, one thing I do want to make note of is you might be wondering, well, really, isn't really this the only code that needs to be in the try-catch block? And I want to reiterate one last time that you should always take the dependencies, the object dependencies, and enclose those in your try block. So, for example, the input object depends on the constructor up here that creates it. If I do not put that constructor inside the try block, when I hit the catch block for whatever reason and go back up here, it's gonna cause problems because it's not gonna know about this object because of object scope, right? This object is outside the scope of these curly braces, right? This kind of goes back to when we declare variables in different scopes. So you always want to make sure that those are in the scope. Okay, for this next example, I've written most of the code already. I'm just going to kind of walk you through it and then maybe take you through a run and a debug of this code. The difference between this code and the code that we saw earlier is that there are two catch blocks. What I'm trying to do is catch two different kinds of exceptions, and this is important because you don't want to catch general exceptions. For example, it doesn't make sense to just catch exception because then you can't do different things based on that exception. The better thing to do is to be as specific as possible as to the type of exception you're trying to catch. And let me just walk you through what's happening here. I'm asking you to enter an integer between 1 and 10. So when I run the program, it says enter an integer between 1 and 10. And if I put in a 99, that is certainly not between 1 and 10. So what will happen here is if the number is out of range, I'm going to throw an integer called, throw an exception called integer out of range exception. And this is a class that I wrote that extends system exception. So when you want to make your own exceptions, the only thing you need to do is make this simple class that extends system exception. And now you've made your own types of exceptions. And you can find conditions under which those exceptions should be thrown and then throw them. So I type in 99, I press enter, and it says your input value is not in the specified range, which is the code that runs right here because I caught the integer out of range exception, not the input mismatch exception. I had a little brain hiccup there for a second. The input mismatch exception occurs when you enter something that's not an integer. Okay, for example, let me run it again. And I type in Tony. You didn't enter an integer. See that? So all there is to it with this integer out of range exception is I've created a class called integer out of range exception, and that integer out of range exception is an extension of what is normally just a system exception. So there's a generic exception called system exception, and I'm extending that with my own custom exception. And then I'm using that exception here. Now normally we wouldn't, you might say, well, Mike, why wouldn't I just write if this then print something, right? And yeah, I certainly could have said, if I is between, is I is less than 1 and I is bigger than 10, begin a curly brace, print this, end curly brace. But, and this is a big but, the advantages of using exceptions is that while this code does exactly what I want today, tomorrow I might not want to simply just print out your input value is not in the specified range. I might want to do something else or something more sophisticated. And by using custom exceptions, all I know is I do my code, and then if an error occurs, I catch my exception, and then I process my code in there. I don't have to write that code in the body of all of my ifs. One last thing to note is that you can print out the exception itself if you want. For example, let me just add this code here. And what I'm going to do is print you didn't enter an integer and then print the exception itself, because I want you to see what this looks like. All right, so let me run that. Let's enter a value of 100. And it says integer out of range exception. See that? And that's useful because now you can log which exception occurred by printing out the exception itself. But rather than printing out to the console, you could print it out to a file or some kind of other logging framework that you might use. Well, thank you for watching this lesson on exceptions and errors in Java. I think what you'll notice is that this is just the beginning when it comes to exceptions. We had to introduce this lesson now because some of the code that we'll be writing in future lessons will be throwing exceptions, and we need to understand the basics of exceptions before we can get into those areas. What I want to point out is this isn't everything that you possibly would want to know or learn about exceptions, but the rest of the things we'll be learning by example as we do the other lessons. That's why this is a relatively short lesson. Again, thanks so much for watching. Post your questions, comments, and feedback on YouTube, and we'll see you again real soon.